We're going to learn in our remaining 12 minutes, we're going to learn two things, integral test and P-series. Here we go, integral test. Alrighty. I'm going to give you like the book thing, okay? If a function f is positive, continuous, and decreasing, for x is greater than or equal to 1, and a sub n equals f of n, then the sum as n goes from 1 to infinity of a sub n, and the integral from 1 to infinity of f of x dx either both converge or both diverge. I'm going to give you an example, and another example, and another example. I'm going to tell you why this works, and then we're going to apply integral test to a special type, a special subset of series called P-series. But here we go. Let's go ahead and try this out. Okay? Does the sum as n goes from 1 to infinity of n over n squared plus 1 converge or diverge? Well, here's what I'm going to do. I'm going to say, okay, I've got this series with all these n's. I'm going to turn all the n's into x's and get the integral. Okay? That's all I'm going to do. Turn n's into x's and get the integral. So I'm going to get the integral from 1 to infinity. Instead of adding terms from 1 to infinity, I'll get the integral from 1 to infinity. And this is going to be x over x squared plus 1. And I'm going to see what that integral does. And whatever the integral does, that's what the series does. If I get infinity as the answer for the integral, then the series has an answer of infinity and it diverges. But if I get a particular number for this integral, that means that this series must converge. Now to do this integral, I'm going to have to do u substitution. U equals x squared plus 1, du equals 2x dx. So I'm going to have to sprout a 2 here and a 1/2 out there. And further, I'm going to do a change of bounds. So when x equals 1, u is equal to 2. And when x equals infinity, u is equal to infinity squared plus 1, which is infinity. And so I get to rewrite this as the integral from 2 to infinity of du over u. Which is going to be the log natural of u evaluated from 2 to infinity, which gets me 1/2 times the log natural of infinity minus 1/2 times the log natural of 2. And that's infinity. So tell me, does this series converge or diverge? What's it? How many people say diverge? Yeah, because I got infinity as my answer for the integral. So the series diverges. Here's why this works. When I get this integral, okay, when x is 1, y is a half, I'm going to get something that looks like this. I'm going to get the area under this curve. This series is just adding a bunch of rectangles, right? It adds a bunch of rectangles where the first rectangle is going to be this guy. The next rectangle is going to be this guy, whatever f of 2 is. The next rectangle is going to be whatever f of 3 is. You see? The area of this rectangle, 1 times a half, that's the first term. And so on. You see what I mean? So do you see that if this integral converges, then the sum of these terms have to converge as well, because these terms are below the integral, except for this guy, but this guy's going to be finite also. Whereas if the integral diverges, if this sum adds up to infinity, if this area rather is infinity, then the sum of these rectangles has to be infinity.
And they don't stop.
What's that?
They won't. You won't
Yeah,
stop
they
adding,
go
right?
forever and ever, yeah. So that's it, you know, the sum of the rectangles and this black area are either both going to be infinity or both not infinity. So here's one I want you guys to do. Does the sum as n goes from 1 to infinity of 1 over n squared converge or diverge? And I'm going to have the sum as n goes from 1 to infinity of 1 over n. Or even the sum as n goes from 1 to infinity of 1 over n to the 3/2 power. So I'd like some people, maybe these 2 rows, to do this guy. I'd like the middle 2 rows to do this guy, and then the far 2 rows to do this guy. Go ahead and do integral test. Converge or diverge. And then I'll tell you what a p-series is. And I'm going to have to cross out the telescoping problems again. So we'll learn telescoping tomorrow, or day after tomorrow, maybe tomorrow, if you guys all get done with that quiz. So go for it. Do an integral test. Why do I keep putting n? by now, you guys should have found that 1 over n squared converges, 1 over n diverges, and 1 over n to the 3 halves converge. That's what you should have found. Any questions or issues on this? Okay, so, hey, now I gotta introduce p-series. If the bell rings, unfortunately, I'm gonna have to keep you for like an extra 60 seconds. A p-series is of this form. The sum as n goes from 1 to infinity of 1 over n to the p power. Don't leave yet, okay? That's a p-series which converges when, you tell me, what has to be true about p in order for that series to converge?
Infinity? Greater than 1.
Well, here, when it's 1, it diverges. So what did you say, Daniel?
Greater than 1.
Yeah, greater than 1. If it's greater than 1, then you don't end up with a log naturally. You end up with this fraction, and you're sticking infinity in the denominator, and it's going to converge. So yeah, it converges when p is greater than 1, and it diverges when p is less than or equal to 1. And that's it. That's it. That's a p-series. And so you're going to get a chance to do some. I mean, hey, how about this? N goes from 1 to infinity of 1 over the cube root of n squared. Tell me, does that converge or diverge?
Yeah, converge.
Well, what's my p here? What's p equal for this guy?
Oh, 2/3 and 2 over 3.
Good, 2/3. So does it converge or diverge? Yeah, it diverges. Yeah, so that's it. Integral test and p-series. That's all the section 10.4 homework is. Okay, are we done? Bye-bye.